Hydrocarbons. Have you got it? This short video checks your ability to use the vocabulary of hydrocarbons and your ability to recognize primary, secondary, tertiary, and quaternary carbons, as well as primary, secondary, and tertiary hydrogens in hydrocarbons or aliphatic parts of any organic compound. The quiz consists of 3 questions. It's meant to be taken after you have studied the material and think you understand it. During the presentation, you'll be asked to pause the video to at least try to solve the problem yourself, and only then to continue. It won't be hardly as effective if you jump to the solution immediately. Okay, here we go. Number 1, what are the 3 functional groups that can be present in a hydrocarbon? Add them to the structure below. Pause the video, think about that, or write that down on a sheet of paper, and I'll be back with you when you return to the video. Okay, well, 3 functional groups include alkenes, alkynes, and aromatic rings. That's all there is to it. Number 2, identify in the structures of morphine and fentanyl taken together one example of each of primary, secondary, tertiary, and quaternary carbons, and primary, secondary, and tertiary hydrogens. Pause the video while you answer this question. Okay, primary carbons. Carbons attached to one carbon. You find it? How about this one right here? Now, are there any others? Any other ends? How about this CH3? Nope, because it's attached to nitrogen, not carbon. How about this one right here? These. Are these primary? I believe they are. Technically, they are primary carbons. An organic chemist might have a question about doing this if the carbons are in a ring, but technically they are primary carbons. Okay, secondary carbons. Well, if you look carefully, we have a secondary carbon here. Here's one over here. Here's one over here. These are secondary carbons. Secondary carbons. Here's a secondary carbon here hiding because it's got the nitrogen, might be hard to find. Ooh, look, I found another primary. Here's a secondary carbon. Hiding here is a secondary carbon. Here's a secondary. What about something like this? Secondary or not? Your book might suggest that that is considered a secondary carbon, but no organic chemist would ever call that a secondary carbon because it's an alkene carbon. And even though maybe technically the definition allows for this, we would not generally refer to alkene carbons as secondary. Okay, tertiary. I believe there is only one tertiary carbon in this whole set, and it's right here. 3 carbons attached. Quaternary, only one here. And how about the hydrogens? Primary, secondary, tertiary. Well, the hydrogens that are on a secondary carbon are secondary hydrogens. The hydrogens that are on a primary carbon are primary hydrogens. Tertiary hydrogens on a tertiary carbon, and there is no such thing as a quaternary hydrogen because if you have a quaternary carbon, it can't have any hydrogens on it. It's already got 4 carbons. All right, just to be clear here, these hydrogens right here, what are we going to call those? Primary or secondary? The answer is these are primary because they're on a carbon that has only one carbon attached to it. All right? Number 3, challenge. Well, actually, I don't think there's much of a challenge here, but still, discuss the difference in how we use the terms primary, secondary, and tertiary in relation to hydrogens, carbons, nitrogens in amines and amides, and hydroxyl groups in alcohols. Also, of these, why can only carbons be quaternary? And why don't we use these terms for ethers or ketones? Okay, think about that a little bit. Pause the video, and we'll talk about these. Okay, here we go. Primary, secondary, tertiary, quaternary. Well, let's start with carbon. 1 carbon attached. Secondary, 2 carbons. Tertiary, 3 carbons attached. And quaternary, 4 carbons attached. All right, now, if we go for nitrogen in amides or amines, it's the same. If we look at hydrogen, it's 1 carbon attached to the carbon that H is attached to. Because hydrogen is always attached to 1 carbon, it wouldn't make any sense to call it primary, secondary, tertiary based on that. We have to go out to the carbon it's attached to and then look. Okay, OH, same deal, right? Because an OH group can only be attached to one thing. It wouldn't make sense to call it anything else. We have to look at the carbon the OH is attached to and then refer to the hydroxyl group as a primary hydroxyl or a secondary hydroxyl or a tertiary hydroxyl group. And that carries through to saying we have a primary alcohol, a secondary alcohol, or a tertiary alcohol. Okay? Why can only carbons be quaternary? Well, think about it. We can have a carbon that's attached to 4 other carbons. But we can't talk about a hydrogen attached to a carbon that has 4 carbons to it because that wouldn't look very good. Okay, what about amines? Well, amines, same deal. If we try to attach a 4th carbon to the amine, the nitrogen gets plus charge, and this isn't an amine anymore. It's called an ammonium ion. Okay, and what about ethers and ketones? Well, if you have an ether or a ketone, it doesn't make sense to use these words at all because there's 2 groups, one on either side of the ether and one on either side of the ketone, and they could be different. So there's no point in referring to these terms for ethers and ketones. Okay, remember, hydrocarbons can contain single, double, or triple bonds, as well as aromatic rings, and thus be alkanes, alkenes, alkynes, or aromatic compounds. And in fact, except for alkanes, they can be all 3 of these. They could be an alkene, an alkyne, and an aromatic compound at the same time if they have multiple functional groups. Carbon atoms and the nitrogen of amines and amides are named primary, secondary, and tertiary, and quaternary for carbon, based on how many carbon atoms they are attached to. So, for example, here we have a primary amide, and we have a secondary carbon, a tertiary carbon, and a quaternary carbon. Hydrogens on carbon and hydroxyl groups in alcohols are named primary, secondary, and tertiary based on the carbon they're attached to. We have a primary hydroxyl group because it's attached to a primary carbon. We have a secondary hydrogen because it's attached to a secondary carbon. Alrighty, well, I hope that was helpful, and I hope you've got it.